Yes, we know that y, this is y, and it equals this, but what does that look like? It's a quadratic, right? So minus 4x squared, so let's even have a look at it. So we've got minus 4x squared, can't remember what I just wrote, plus 7x, take 3. Okay, so there she blows. And what we want to do, and what we did first of all, we said if we have a point, let's say 2, we want to find the slope at that point. We know it would be negative, wouldn't it? Slope at, say, minus 1 would be positive and quite steep. Now, if we had a specific point that we wanted the slope at that specific point, we could use f of x minus f of a, that other formula, yeah? But we don't have a point that we are wanting, like we might go, oh, I want it to be 1, I want it at 2, I want it at minus 3. So what we want is to get the derivative function. Yeah? So to get the derivative function using first principles, and this might be the last time we do this, long-winded, because you're going to get the shortcut pretty soon. We use limit as h tends to 0. So this is a formula that you will just have in your minds because you love it so much. Okay, and basically what that is doing is we've got a quadratic. We're saying, okay, there's some point here, let's call that point x, and then there's some point a little bit further away, so x plus h, so h units away, and we're wanting to make this come closer and closer and closer until h is actually 0, so we get the slope at that point. Happy with that? So we want to make h equal 0. Sask, the aim of the game is to make h 0, but we can't do it straight away because then we're going to be dividing by 0 and cray, undefined, no good. So the game plan is we're going to hopefully pull out a common factor of h from the top line. Now, if you know that, everything else is just following instructions. Would you agree? So what is the first instruction that this is telling you to do? First instruction. Right, go to your f function, and wherever x is, we want to replace it with x plus h. It is speaking to you. It tells you what to do. So we write minus 4, but instead of x squared, it is x plus h squared. That's not difficult. Instead of 7, it's x plus h. Those of you who did the homework and you go, I've got this under control, you can either stick with us or you can look at all of the results that we've had so far and maybe make a table and see if you can find a shortcut. Got take 3 minus, what's it then telling you to do? Thanks, you're just the point. It is telling you minus the function itself. Now keep in mind, right, you're minusing all of this. So you should put brackets around it, yeah? I'm going to be a little bit lazy because I don't want to write this out another line. So I'm going to go minus 4x squared, so that becomes plus 4x squared, minus positive 7x, so that's minus 7x, and minus 3 becomes plus 3. Ooh. All over h. And I go, geez, deadly. In the back of my mind, we've got that thing of we are going to need to cancel out, we're going to have to pull out a common factor of h on the top line. So this is giving me hope because that doesn't have an h, but what is minus 3 plus 3? They're going to cancel out. So anything that doesn't have an h is out of there so far. So that's looking good. If you had stuffed up with your minus here and you ended up minus 3, that should alert you to go, ooh, hopefully I'll get a 6 somewhere here, and then they will cancel. And if it doesn't, go back to that spot. Anyway, carrying on. Minus 4 times x squared plus 2xh plus h squared plus 7x. Writing very squishy now to fit everything in. Shall we cancel out the 3's while we're here? Because I don't think I'm going to fit everything in. Goodbye. Goodbye. And we've got plus 4x squared take 7x. Ooh. All over h. Things are looking snazzy. Why are they looking snazzy? That's, I wrote 2 7x's. That should be an h, shouldn't it? Thank you. That should be an h. Okay, snazzy, snazzy, because that 7x cancels out with that. And again, they're things that don't have an h, correct? Okay, so what have we got? Limit minus 4x squared take 8xh minus 4h squared plus 7h plus 4x squared. And really, you shouldn't be just copying what I'm doing because, you know, you can expand. I know you can times by -4. Are we confident with what's going on? Like, should we be confident that we're on the right track? Why? Because the minus 4x squared doesn't have an h, but thank goodness we've got a plus 4x squared and they cancel out. So things are looking, they're going our way. And now, all that's left to do is the things that are left, we pull out that h. So we get minus 8x minus 4h plus 7 all over h. They cancel out, and it is at this point that I can now replace h with 0 because it's gone from the denominator, and I can therefore say f dashed of x is minus 8x. What's 4 times 0? Nothing. That's out of there. Plus 7. And we're done. There's a distinct pattern. So sorry, stop recording then, but we're just summarizing all of the functions that we had and the derivative that we came up with using first principles. And there is a distinct shortcut if you haven't read ahead, one hopes. Al, did you read ahead? Did you read ahead? You've read ahead, haven't you? Then don't play with us. So, have a look. Clear pattern. It might help you if we do it in order. So when we had 1, the derivative was 0. When we had x squared, when we had x, the derivative was 1. And maths, let's face it, is all about finding patterns in life. Does anyone want to have a go at what they think x to the 5 would be? 5x to the power of 4. What about x to the 6? 6x to the power of 5. What about x to the... Yeah, I wasn't going to go 7. 9x to the power of? 8. So then, what if I had x to the n? You know, you're putting the power out the front, and then what are you doing to the power? You're taking one away. Look up the top of the purple one. Right? You've just come up with, that is your rule for finding the derivative at a particular point, how to get the function. So you don't have to do the whole first principles anymore. Oh, there you go. There you go. Look at that. And the jacuzzi way. Why did you show us that? It is it is in your outline for year 11. It is also in your outline for year 12. So you used to be able to be guaranteed in the exam at the end of the year, there will be a question find or show that this is the derivative using first principles. So you have to show all of that. And they were like, out of 6 marks, if you didn't put the limit, you lost 1 mark. It was all that stuff. Now the exam's worth 2 hours, so it's a bit more hit and miss whether you get it or not. But it's worth. It's like if you don't teach it, you're just giving away 6 marks of that lobbed into an exam. And look, now what you'll be able to do is by knowing the shortcuts, you'll be able to go, yeah, I know that I'm right or wrong, and check immediately. Okay? So at the moment, we have this one. We also, if we go back to here, when we've got 1, what did you expect if it was like, what if we had 5? What would be the derivative there? It would also be 0. So can you explain to me again? You did it last week, but explain again. Why is the derivative of constant equal to 0? Pardon? Because there's no x. Think graphically. What happens? Yeah, it's so not just straight line, because let's face it, I could have a diagonally straight line, but y equals 5, y equals -7, y equals any constant is actually always going to be a horizontal line. And what do we know about the slope of a horizontal line? 0. So think about what it is that you're actually doing to put everything in context, and I think that helps with your understanding, I hope. All right. If you have a number in front of x, so if we've got y, if we've got f of x equals 5x cubed, what is our derivative then? Yeah, so if there's a constant in front, doesn't matter, you still bring that 3 downstairs and you multiply what's there. So 3 5s are 15. And then we take away 1 from the power 15x squared. Yeah? So, the 3 rules that you will write down at the tippy top of your page are these. Okay, so, we've got those rules. We also know that we're talking about the instantaneous, I'll write that again, slope at a point, another way to say it. Instantaneous is the instantaneous rate of change, as opposed to, right, instead of the slope at a point, the slope between 2 points. That's what we had before. Or the average rate of change, that was between 2 points. But now we're going at a specific point. That's what we call the derivative. Slope at a point, instantaneous rate of change. Now the symbols that we've got so far, we've got f dashed of x. We're happy with that? Here comes one more. Didn't want to give it all at once. When we've got f of x, so if I've got f of x equals blah, 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 that's meant to be blah, 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 then we say f dashed of x for the derivative. And this isn't a deal breaker. I mean, I tend to mix it up. It doesn't really matter. But when we've got y equals da-da-da-da-da, it's a bit kooky to write f dashed of x if you haven't used f of x. So the alternative for that is dy by dx. It's the derivative of y with respect to x. Now, just means the same. If, Laurie, I write a question and I say y equals x squared, what you should then do if you're finding the derivative, dy by dx equals. But you might rewrite it and go f of x equals x squared, then use f dashed of x. It doesn't matter. Okay? Am I going to deduct marks if you switch it? No, I won't. I might go, ooh, yeah, weird maths, but you'll see me. I'll switch every now and again. Okay? So not a big one. Just as long as you see if a question says find dy by dx, it's just going, yeah, find the derivative, find the slope at that point. We good?
They all survived.
Hi, Miss.